So yeah, for homework question 9.17, it gives us this arsenic tetrafluoride, which is in the trigonal bipyramidal electron domain geometry. And then it asks, what would the bond angle be for the fluorine, arsenic, fluorine bond from A down to fluorine B? And yes, if we were in traditional trigonal bipyramidal structure, you'd expect that bond angle to be 180 degrees because they're going to be exactly, perpendicular, or not perpendicular to each other, but they're going to be 180 degrees from each other on that axis. This would be one of those exceptions because these lone pair electrons, they actually occupy more space. And because they occupy more space, they actually push these arsenic fluorine bonds a little bit out of planarity, right? So it's going to be a little bit tilted. I guess I should keep it the blue color. It's going to be a little bit tilted in and a little bit tilted in. So that bond angle is actually going to be a little bit more than 180 because of that. So, I would say, okay, well, I guess they're looking at it from this side. So from this side, it's less than 180 degrees. It's less than 180 degrees on this side because our lone pair of electrons on the opposite side is going to push it a little bit to the right for both of those. So again, though, for the exam, I just want you knowing the main bond angles. You don't need to know the slight exceptions, but anytime we have a lone pair of electrons, it usually shifts the bond angles a little bit out of what we normally expect them to be, just because those electrons occupy more space, and all they're doing is trying to minimize repulsion. So they repel the electrons in this arsenic fluorine bond. So instead of being 180, they're a little bit like this instead. Yeah.
So like for the example, just kind of have to know like the like for each electron domain, like what that
The main bond angles. Yeah.